I'm Anil Kumar, and in this video we will understand characteristics of reciprocal functions. Question is, determine the domain and range, intercepts, positive and negative intervals, and intervals of increase and decrease for reciprocal of f of x equals to x squared minus 4. So I've listed all the characteristics here and we'll look into them one by one. This is a very important video and forms a base for rational functions. So let us first consider the function itself. So what I will do is sketch the function and then we will see how to sketch reciprocal of that function, right? So I'm just making a rough small sketch for the function. We'll look into details of sketching later. Now first part is the function, which is x squared minus 4. It is a parabola which is kind of like this, where the vertex is at minus 4 and the intercepts, the x-intercepts will be where? F of x will be 0 for x equals to plus minus 2. So these points are plus minus 2 for us, right? Plus minus 2. Now that is the function. As you can see, the function has divided the plane into three parts with its x-intercepts, right? Now let us consider the reciprocal of this function. When I say reciprocal, it means what? F of x is this. So what is the reciprocal of f of x? Reciprocal means 1 over f of x, right? So that really means 1 over x squared minus 4. So that is the reciprocal. Now this is the graph of the function f of x. Reciprocal will be, we'll have to write reciprocal of each and every value on this graph. Now what is the reciprocal of 0? Here at the x-intercept, the y value is 0, right? So for the reciprocal function r of x, we will get a vertical asymptote here. 1 over 0 is not defined, right? So this is not in the domain of reciprocal function. So we'll get vertical asymptotes at the x-intercepts of the function. Important to understand, right? So that's the first thing. Whenever you are sketching a reciprocal function, start with the x-intercepts, convert them to vertical asymptotes. Next is, in this particular case, y-intercept is minus 4. Reciprocal of minus 4 will be minus 1 over 4. So this point is minus 1 over 4. So that will be on our graph. Remember, reciprocal of positive will be positive, of negative will be negative. So on this side, which is the left side of the first vertical asymptote, let me call this vertical asymptote at x equals to minus 2, where the graph is positive, reciprocal will be positive, and wherever the value is 1, let us say these are the values which are 1 for the function. These are the invariant points. So at this point, we'll have a common between reciprocal and the function. So the graph of the reciprocal will be like this, like 1 over x curve. As the function increases, the reciprocal value decreases. If the function decreases, the reciprocal increases. As function approaches 0, reciprocal approaches infinity. That is how it is. So similarly, let me draw both sides of this graph, right? The center portion is negative, reciprocal will be negative, minimum becomes the maximum, and as the function approaches 0, the value of the function approaches infinitely large, right? So here again it will be kind of like this. Do you see that? These are the points where the value of the function is minus 1. So plus and minus 1 are the invariant points. Now we have a rough sketch of reciprocal function. Let us write down all the characteristics one by one. for the reciprocal function, right? First part is the domain. So domain for the reciprocal function is x belongs to real numbers. But these 2 points, which corresponds to x-intercepts for the function, are vertical asymptotes here. So x is not equal to plus minus 2. Now let's look into range. Range is y belongs to real number. You will notice that the function approaches 0. Horizontal asymptote is y equals to 0, right? So in this case, we have horizontal asymptote y equals to 0. That is to say, as x approaches infinity, y approaches 0. As x approaches minus infinity, y approaches 0. So horizontal asymptote is 0. So y is never at 0. It is approaching 0. So y belongs to all real numbers except 0. So we can write this as y not equal to 0. So that gives us the range. The x-intercepts. Since y is never 0, there are no x-intercepts. Now this is true for all the reciprocal functions, right? Y-intercept. In this particular case, the y-intercept is at y equals to minus 1 over 4, right? So let me write 0 minus 1 over 4. Y-intercept is at minus 1 over 4. Now we are looking into the part of the graph which is positive. We can see it is positive from minus infinity to minus 2. And let me write union from 2 to infinity. And it is negative in between minus 2 and 2. Increasing. The graph is increasing in this interval, right? It is increasing here also. Do you see that? So the graph is increasing from minus infinity to minus 2, and then from minus 2 to 0, right? Remember, there is a discontinuity in between, therefore we have to split it like this. And where is the graph decreasing? You can see the value decreases from minus 1.1 over 4 to minus infinity, from 0 to 2, and then it further decreases from 2 to infinity, right? So on this right side of x equals to 0, the graph is decreasing. And of course 2 is not in the domain, so that's why we have 2 different intervals here. I hope you appreciate it, right? So what you see here is wherever the parabola, the function decreases, in those intervals reciprocal increases, right? Wherever the function is positive, reciprocal is also positive, negative, reciprocal is also negative, right? And the x-intercepts of the function translates to vertical asymptotes for the function. The end behavior, where the function is approaching infinity, reciprocal is approaching 0, right? So that is how we can relate the function with the reciprocal function and understand different characteristics. I'd like you to have a good look at it so that you understand exactly how we can describe reciprocal of a function, right? We'll take a couple of more videos and try to describe in the similar way. I hope that helps. Thank you and all the best.